to understand the product rule in differentiation, we need to understand that a product is area, which is generated by length times width. So those are two factors of the product, is length and width. So the product rule states that the change in the U times V is equal to U times the change in V plus V times the change in U. So we have here this model here where along the y-axis we have the V function, and along the x-axis we have the U function. Okay, so as we change the t value, okay, so this is U of t along the y, V of t along the y, U of t along the x, and as we change the t function, as we change the t value, we're going to change the length of U and the length of V, or the length and width, and so the area changes. Okay, so that's what's happening when we think of a product. This is our product. Along the y-axis is one function, along the x-axis is another function, and the area inside represents the product. So the product rule, the derivative of a product, essentially saying how does the area change as we change this, as we change the t value, as we increase t a little bit. So if we take a look here, as I change my t value, the change in the area is going to be generated by this little red area here, the purple area, plus this little rectangle in here. So this is my U function, so the length along the x-axis times the width of how V changes, okay, how the vertical changes, and then this purple area here is going to be the V function times a little bit of the change that's happening in the U. So these two areas essentially are what's going to drive the change in area. There's this little bit extra in here, but as we let H go to 0, notice that area in the top right-hand corner, that area becomes insignificantly small, because remember that we're doing very small changes in U and T, in the dV and the du function. So this area then that the change is represented by this U times dV, okay, and the V times U. Thus, that's how we get our formula. So the change in the area is the U function times dV plus the V function times du, and then that top area, which is actually the du times dV, that area becomes insignificantly small, and we just ignore that part.